because in week 12, holy cow, it's already week 12. So basically only one more week after this one. Basically in this week, we're going over indexes and constraints. And it's the way the course is kind of like laid out. It's kind of funny we hit this because especially for those of you working on a final project, you've probably either dealt with this or have seen the options for it and maybe didn't utilize it to the full extent. But indexes are really kind of like the last kind of key that you learn when you're dealing with databases, because it's in most cases used for optimization. And same thing, and constraints are the same way. They deal with optimization and data cleanliness. And I guess just as an example, before we really dive into the sequel, is what I really like about indexes is that they just make sense. It's kind of like back in the day before we had computers, people had to index libraries by hand, which is really interesting. And there was actually a lot of very strong feelings about how you might go about indexing your data, your catalogs, your inventory, so on and so forth. Basically, whenever someone's trying to find something, whether it be an academic journal or a book or something similar, you want things organized in a certain way, especially when it comes, I really like the book analogy because it can change based on how you're approaching what you're looking for. So for example, like if I'm looking for a book by a certain author, that's, easy to do. But what if I want to look for a book by the title? I don't know the author, but I know the title. Or what if I know, I'm looking for all the books that deal with, geology, and so depending on how you organize, since books historically have been physical, it's not like you can say, well, I'm just going to keep a copy of this book over here in the geology section, but have this shelf organized by authors, so on and so forth. So what's really interesting is depending on how you laid out your library, you would have these additional, and I'm pretty sure we've all seen them before, those the index cabinets where they like, an index card. That's kind of where that came from. But, just as a quick reminder for any of you people that might be old enough to have come across these, this is an index cabinet, which is basically what they use to kind of do the index. So as we're going through this process, be thinking about the physical way to do this is kind of how I'm going to describe it, because in ways they're a lot the same. In fact, more than most kind of physical to digital comparisons that I've done for a lot of the things. So what an index does is it will allow us to make our data quickly findable. So that's why we're kind of learning it here at the end with indexes, is because indexes allow us to make it quicker to search out individual records or subsets of records. Really valuable when optimizing queries. So if we're running a query that just takes a long time, and believe me, I've had queries that even optimized take up to words of 10 minutes to run or more, and so this can become very important and very impactful to how you kind of manage your data. And so the way it works is we choose a column we want to index. So in this case, like if I'm looking at the customer table, let's just select everything from customer. Taking a look at this, one of the most common things we might use to kind of search for customer is email. Additionally, last name, first name. For right now, I'm just going to put an index on email, and this one is going to do both a constraint and an index. So the difference between an index and a constraint, an index, basically just like the index cabinet, is going to kind of create some additional metadata about our data to make things quickly findable. A constraint is going to change how it's going to constrain what data we can put into that table. So if I put a unique constraint on the email table, basically it means that only one version of that email can exist, which makes sense. We don't want two people with the same email necessarily. I mean, it could change, but if we're using this table to log in, for example, We probably don't. I don't know if do we have a system user table? We do. So let's select, that might just be our employees though. System user. Oh, and that might just be something I made. So if we're looking at our customer table, let's pretend that this is where people log in. We don't want two people to have the same email because then that becomes cumbersome. What if someone resets their password, yada, yada, lots of security concerns, etc. So we want to put a unique constraint on the email table, but also we want to put a unique index because that'll make it faster. So I'm going to just walk through that process. So we're going to create unique index, and then we give our index a name. So in this case, I'm going to call it customer UQ1 is usually kind of the way I do mine, unique one. And we do it on customer email. So there we go. Now you'll notice that I actually got an error and it says that there's a duplicate key name, customer unique one. So I might have already have done this, which in that case, we will just drop it. Yes, so let's just real quick drop this constraint, drop unique index customer U1. And let's see. Other table. Can't remember for MySQL how to drop that. So let's just do it like this. We'll see what it tells us. Indexes. You want to delete the selected one. Apply. Yeah, I don't know why it was getting upset at me here, but for some reason it didn't like it. Let's oh, and it might be because I don't have the right database selected. Use. All right, so we are going to alter the table customer. We're going to drop the index customer unique one. There we go. And now we're going to create our index. So we're going to create unique index customer UQ1 on, and then we put the table name and then in parentheses the column. So there we go. So now I have a unique index on my email table on my customer. So now what this is going to do is it's going to basically make it so I can't have two of the same email in this table. If I were to try to do it, it'd say, hey, you can't do that because at this point you'd be violating the constraint that makes email unique. Additionally, it makes it much, much faster to query our data. And there's a really cool utility that we can kind of use to visualize just the difference. So I'm actually going to do that. And actually, I think we can do it here. Let's pick a customer we want to use as an example here. We'll pick one a little further down. Let's use Andre Rapp. All right, let's try it over here. So there's these really cool tools, and I believe you'll read about them in the book. In fact, let me actually check the reading notes here just to make sure that they are in there. Pretty sure we can see. Indexes, error messages, types of indexes. All right, so this explain, this is pretty cool. So there's a couple different versions of this. The first one is explain. And explain is how we can kind of find certain, it'll kind of show us basically what goes on in a query. So in this case, we can kind of see what key was used to find it, what possible keys there were, which key it used, and basically the total kind of, there's a way in the next one to kind of see the total kind of cost. So let's look at this. So in this case, where we're selecting customer, we can see that basically it says rows and filtered is 100%. So I'm actually going to drop this constraint here again, and I'm going to run this. And you can see here how, the select type is simple, yada, yada. Possible keys is null, the key is blank, all this stuff is blank. And you can see that basically the amount of data that this query parsed was 600 rows and filtered as 10. So somehow it filtered out 10 rows and basically had to parse through the rest to find where the email is equal to this. Now, if I put the constraint back on and run this, now we can see that, okay, because it was able to use the key, it only had to iterate through one row. Basically, it could identify it immediately, which is pretty cool. Really cool, actually. Does that make sense to everybody? Kind of like a basic idea of indexing.
That makes sense to me.
Perfect. All right. So let's see, there's one more thing, and I can't remember quite the name of it. There's a way in MySQL we can see the total cost. Execution plan. Plain. Extended. Let's see if it just pulls up in the terminal. Let's paste our query in here. This will at least let us see the seconds here. And there is a way to turn this on. I think we just need to turn it on. Should be really cool. Let's see here. It might be in a different actually I think it is in Postgres, and I'm thinking that it shows a cost. So anyways, but we can look at the total number of seconds. So this was with it on. Let's drop it from here. Let's go back here and just rerun our query again. With everything. Oh, and the seconds don't go longer. But anyways, if we had more data, you would actually notice a big time difference between these two. Now, one of the biggest kind of problems is that as we think like, oh, like indexes make querying a lot faster. The problem with it is so you think, oh, let's just build indexes on pretty much everything. The problem is that as we do so, it's going to create more and more space. Just like what I really like about the index cabinet analogy is that the more we index on, the more physical space we're going to use. Just like as if we, if we were going to index on every column and every row, or for every possible way you could look at for a book, you're going to have 12 or more, physical cabinets. And so that's why we don't index on everything, because for every index we add, the database actually kind of creates this metadata that kind of, I guess, takes up more space. It's almost like a hidden table. And so kind of an analogy on how this works. So we kind of saw unique index, but let's say that I just wanted to index a given column. So I'm going to select everything from payment. And we have this payment date in there, which is something that we're probably going to use in reporting quite a bit. So, I think payment date is something that is worth the cost of indexing because it's something we're going to use a lot. Whether it's we want to, find the total revenue by day, month, quarter, etc. So we want to create an index on payment. So let's just make sure there's not one here. Okay, doesn't look like it. So it looks like we have one on staff, but not on payment. So I'm going to create index, and I'm going to do it, call it payment IDX1 on payment. All right, so there is my payment index. Now, basically the way this works, depending on the data type, it can always do this differently. But, with payment date, something that the computer might do, and this is indexing is kind of one of those things that are highly kept secrets when it comes to the people who create them, is that, if we wanted to make data faster to find based on a date, what we might do is we might order the data, the payment, least to greatest, and then we might segment that data into given chunks, and maybe that's by year, maybe that's by month, maybe it's by day, so we can quickly find it. So for example, rather than iterating through every row to try to find, like a given date, what we might do, even if it's like, if we're looking for this specific time, 2005 July and the 8th of July. If we're looking for these particular records, if we have our dates segmented into like quarters, and the computer knows that, I know that this date is going to be within the first quarter. And once I get into the first quarter, I know it's within the first quarter of that quarter. It can go from having to search through, 600 records down to just, 10, which is obviously going to optimize, because it can basically look through its index metadata and kind of key in where to look. And same thing when we index like email. The reason it was able to go right to it is because we had few enough records that basically it keeps an index of exactly where in the table, where in the actual physical data that record resides. And so if we had tons more data, it might not know exactly which one. Like when we index email, it might go, to a specific like subset, and it might still parse 10 records. But because we did that, it's going. So let's actually try this, and let's just see how many records it goes through. So where payment date is equal to 2005. I guess we better get the date of payment date. It's equal to 2005 and July 8th. Again, let's explain this. I guess I need that. All right, so if we look at this, and apparently there were no keys that it could use. So it actually went through all 16,000 of them. Did I get that on there? That is the question. Duplicate key is on there. Payment IDX1. Did I? Yeah, that should be there. Let's try that. Oh, and so another thing. So the other reason that this might not work exactly how we want it to is because we're using this function. So let's actually take this function off. So the one thing about optimizing query is the more functions you use, the worse it's going to perform. So now that we took off that function, it can use that index. And that index now you can see that we're using that index and it became a lot more efficient essentially. All right, just to make sure, because I know we need to cover the bitmap. So there's a couple different types of indexes, and knowing which one to use is important because they're depending on the type of data you have, they'll be faster. So the first one, a B-tree index, this one balances out buckets essentially. So a B-tree index is really good for basically all kinds of data. So for example, like what we just did on the date, B-tree index is probably best. A bitmap is good for when you have categories, few categories like flags. Flags are really good for bitmap because it can really lump things into buckets based on the category, or what we like to call factors. So B-tree indexes are really for kind of narrowing down, and it works for all kinds of data types. And actually, this is a good example. So B-tree will go through. So like I said, like if we were doing dates, it would say, oh, the year 2004 through 2010 is in this bucket, and I'm looking for 2005. And oh, and then in there, 2005 is right here. So it can very quickly exclude a big chunk of data very quickly without having to actually parse through those records. And same thing with alphabet. So you can kind of see here, like, oh, if I'm looking for something that starts with an A through M, I go into this section of data. So that way I don't have to worry about all of this. And then once I get here, furthermore, I can isolate further down to where I'm just looking for a particular subset of records. So B-tree is good for things that can't be, these can be categorized, but versus a bitmap, it's going to actually factor. I like to think of it like if all you had were, a few bins, then a bitmap is perfect. So yeah, this will kind of walk you through like how you can create a bitmap. So like, for example, on our customer table, and I think this is the same example it uses, in our customer table, there is a active flag, active, and it would probably be a good idea to create a bitmap on that. And I think this is the one they use particularly for this one. Yeah, so they actually put it on that same one where basically they create this bitmap index. And that's basically, so since there's only two options for that particular column, so if we say select distinct active from customer, we only have two options. So this is a perfect candidate for this bitmap. It really doesn't like certain things being copied. Anyways, but we could create that bitmap index. And the difference is you kind of say what kind of index you want to create. So just like we did the create unique index, we can also create our bitmap index. So create bitmap index customer. And I don't know what's going on.
Does my SQL use it? Because I thought the reading said it's just Oracle.
Maybe is that what's going on? Oh, yep, you're right. Yep, you're right. Wow, I'm actually surprised that MySQL doesn't have that. Okay, I guess that's another one of those. Because I know I've said this before, but Oracle actually maintains MySQL. Oracle is the paid version, and MySQL is the free version. So, while I'm surprised that they don't have it, it makes sense why they don't, because that's one of those things that might cause you to say, hey, I might upgrade. Perfect. And then the last type of index is a text index, and basically it's a full text index. And these are the ones that are very expensive, I guess to say. But these are something that's very handy if you want to search through actual text. So if you're going to be looking for like subsets of text within a column or anything like that, these are really important. So a good example might be if you had a database that kept track of all the URLs. So as a good example, we actually did this at my previous job. I was helping the IT department. They were logging all of it was at a school district. They were logging all of the students' URLs to a database so they could monitor and make sure everything was good. And just basically make sure that nothing was going on that shouldn't. But as a part of that, we were logging the URLs, the full URLs, but really all we wanted were the domain names, right? We don't care, if you're at, we don't care if you're at bbcnews.com or bbc.com/news. We just care that you're at bbc.com. So basically, they wanted to be able to search for certain records based on just the single domain name. So like, oh, give me the total number of hits that Netflix had, because that's how they kind of help monitor their bandwidth and stuff like that. And so basically they would, this query was expensive. You can imagine a whole high school full of students, and all the URLs that are being hit. This is across the entire network, which was just massive. And so what we had to do is we had to be really smart about how we index things. So we had a date index and we had a full text index on the domains or on the URLs. And that was so they could search for specific domains within those URLs, which in fact, the first time they tried to run the query, wouldn't even run. I actually think they left it running overnight and the server ran out of memory or something happened. It timed out or something. So that's when they kind of enlisted me and I kind of went through the query and we optimized it and got it to work. But that was a big thanks to the full text index. Let's take a look. I think that's it. We talked about how to use it, the index results we went over. Downsides of indexes is that they, they can be expensive because, and this is kind of like the funny comment. You should not have too many indexes, but also don't have too few, kind of contradicting, like, obviously that's the goals, but you want to have a nice balance is essentially what it's saying. So you really want to pick which key columns are being used the most. So if there's something specifically you put in the where clause frequently, that's something that you should examine and say, hey, is this something I want to index? So for you guys that are working on your final project, you'll be able to look through your CRUD statements and your test cases, and you'll be able to say, man, what column am I using in my where clauses? And those are great columns to index, specifically if you're looking for like a single record, right? You definitely want to index those columns. We talked about constraints. One thing we didn't talk about is normally you create the constraints with the table. You can do it before or after. And there's kind of two types of constraints. There's an inline constraint, and then there's an out of line constraint. So all of these little not nulls that you see here, these are a constraint, meaning that it can't be empty. So if I put a new record into customer and I leave out last name, it's going to say, hey, whoa, you can't do that. This can't be null. That's a type of constraint. And that one in particular is an inline constraint because it's defined on the same line as the column. If we wanted to do another constraint that's out of line, you can see that these are just kind of like thrown down here at the end of the table. So there's kind of the two ways while you're creating the table, but you can always use an alter table statement to kind of put it in there. Just like we talk about here. And sometimes you have to disable constraints. So you can actually disable a certain constraint, because sometimes, as many of you might have find out, if you're trying to insert certain data into a table and it says like, hey, you can't insert this before you do this. And anyways, you can always disable it if you want to kind of brute force it. All right. I do go through, in cascades. I think we talked about this when we went through how to build tables for the final project. But when we have a foreign key constraint, so for example, if I'm in customer, we have our customers here, and we know that there's customers that have payments. So if I were to look at our customer with payment here on this day, and I guess I need an 0 there, and apparently that doesn't even work. 8. There we go. So let's look for a customer. So let's just say customer 1. Select everything from customer where customer ID is equal to 1. All right, so if I wanted to delete Mary Smith, right now in this day and age, and really across databases, we rarely want to delete data. If I'm being honest, the key, really what you want to do is you kind of want to, and this might scare you a little bit, but most of the time, like even when you think you're deleting something, what they'll do is they'll just add a column that, says like consumer deleted flag equals 1 or 0. So like when you say, I'm going to hit this delete button, even though it disappears from all your views entirely, that record still may be there because there's important insights that we might garner from what people are deleting. So you can imagine if you're Amazon, right? Just as a scenario, you can imagine if you're Amazon and we want to gain insights about, how our customers behave. Let's say that they put 2 things in their cart, right? Like let's say they put an Amazon Fire TV and a Roku TV in their cart. We can look and see which ones they add, but it might be also just as interesting to see which ones they delete from their cart. So like when they add and remove stuff from their cart, I think it would be a fair bet to say that they're probably tracking what you add and remove from your cart. So when you hit the delete button, oftentimes you're not actually deleting a record in the table. You're just updating a record in the table so that they know to hide it from you to make you think it's deleted. And there's a lot of reason behind that. A lot of it's because there's interesting insights to garner, because then not only do you keep that historical record of, oh, they added the Roku TV to their cart, but we also know that they deleted a Roku TV from their cart. So to speak, and something that might be interesting is, let's say that they, added the Roku TV to their cart just by itself. Let's just say they added a Roku TV and, they know how long it's in there. As they delete, as a user, you delete it because you say, that $100, it's just too much. So they delete it, and so, but then let's say that, Amazon's watching this and they say, hey, we have X number of customers that are putting this in their cart, and, 90% of them after 3 days are deleting it versus the other, small percentage that are actually buying it. And so then maybe Roku decides to have a sale, and maybe that sale means that, of all these people that deleted it, maybe we should, put it on their list of things to buy, so to speak. So lots of ways you can kind of use that to kind of monetize. But anyways, I digress. But if we wanted to delete customer, like actually delete this record, I actually couldn't, because delete from customer, where customer ID is equal to 1. If I try to delete this, you'll notice that it says cannot delete or update a parent row. A foreign key constraint fails. And that's because it's depending on a certain other table. There's another table that depends on this. Maybe it's payment, maybe it's another one. But because customer sits higher up in this hierarchy, if we were to delete it, what do we do with all the records and the tables that sit below it? If we keep them, then we forever have what's called an orphaned row, is what it's called, for obvious reasons, because its parent's gone. We have no one to attribute this payment to. And so now, if we were to look in payment, we'd say, oh man, we have, this money here that we just don't know who the customer was, which is never a good place to be, which is why really deleting data is something rarely done. And that's why by default, when you build this foreign key, those constraints are in place. It's there to protect the data. And so basically, when we define these constraints, there's certain things we can do. And you may have seen this when we were doing our final projects, but like if I were to go into payment and edit this table and go under this foreign key place, you'll notice when I click on customer, which is kind of our foreign key, over here, there's this foreign key options and it says on delete restrict. Basically, that's going to say, hey, you can't do this. And we have a couple different options here. We can restrict it, which means it's not going to let me delete the customer. We can cascade, which means that if you delete the customer, I'm going to delete the payment, which is a scary thought. If you ran cascade all the way through your data, you could delete a lot of important data really fast, especially like if it's on accident, like, oh, I want to delete this. Like, for example, back to, I used to manage data for schools, and we used to have parents, register their children, and oftentimes they might duplicate a child. Maybe the mom and the dad both kind of do one, and I'd want to clean that up. And so what we do is I would just delete that person. Now, I had all my data set to restrict, so I could very easily say, hey, you know what, this is the duplicate. If I issued the delete statement and it worked, fine, but otherwise it's going to fail. And so if the parent had gone in and put in an address or any other information for that child, it wouldn't let me delete, which is actually what I wanted. Because if I had accidentally typed, an existing student, let's say a senior is ID 2, and I just misread the row number, right? And I deleted that, all of his grades, all of his GPA, everything he's ever done, all of his assignments wiped out in an instant. So those cascade options are really, really important. All right. Let's take a look here. So that's why we had that cascade. It's going to talk about the different options. You can set it to be null, you can restrict it, etc. And that's for deleting or updating. Anyways, those are those constraints. Another interesting constraint, and I think I go over this, is there's what's called a check constraint, which will actually restrict what kind of data you can even put into a column. So like if you wanted to do yes or no, or biological gender or something like that, you can restrict certain values that can be inserted beyond just the data type. Anyways, that's all I had. Does anyone have any questions about indexes or constraints?
No, but I'll just add that this answered some of the questions that I did have. So
Perfect.
thank you.
Yes. And just, like indexes are one of those things that, and like I said, there's very few things that I think like, oh, think of how you would do it manually. And indexes are one of those things that I think makes sense as far as like how to think about it. If you had to index a library by, 3 different categories, you can only have the books laid out in a certain way. So maybe we organize the books by author last name. Great. If we're looking for the author by last name, then that's perfect. But like I said, if we want to find all the books that are in the nonfiction category, now all of a sudden those books are dispersed at random based on, seeming random based on the author. And so then it might become more difficult, or, based on what we're kind of looking for. Or if we're looking for title, basically it would be good to go to the index cabinet, and then we can find like, okay, it's organized by author, but if you're looking for Harry Potter and the Sorcerer's Stone and you're crazy, live under a rock, you don't know that J.K. Rowling wrote it, you could go to the index cabinet, search by the name, go to the little H slot, find Harry Potter. You'll be like, oh, this is on aisle 6 and it's shelf 5. You know what I mean? So,
Mhm. Yeah, that's great. I've had, it's the foreign key that I've been, once I'm down to like the last two tables, and now I can't set and move data around because there's all the foreign key constraints. So that's what I've been struggling with. So this was helpful.
Got it. Yep. Yeah. And those foreign key constraints, they can be, as much as they're helpful, they often are a nuisance, especially when you're in kind of developer mode.
Mhm.
Which is both good and bad because you got to test it. But just so you know, you can always disable them and just
Okay.
re-enable them. And just so you know, let's see, I think it's just as easy. So let's just find one here. So like if I
Yeah,
want,
mine's like I said, it's like, I'm on like table 11 or something, and I can't insert my data because of a foreign key constraint.
right. I think there's a way we can just disable that. I know in Oracle there is. Disable constraint. Yeah, so this one's in bulk, which I don't necessarily like. In Oracle, you can actually just disable a single constraint. But basically, if you want to bypass it, you can just say set foreign key checks equal to 0, and that will turn it off. And then once
Okay.
you kind of get it there, you can turn it back on. But the important thing to make note of is to understand, is this broken? Because sometimes you'll put the data in, go to turn it back on, it'll say, oh, I can't turn it back on because you broke the rules. which like, it's okay to use it to get around it. And just as a good example, let's just walk through, because that's a good point. So if I were to create a table, because this is one thing we've never really talked about, but a great example of why you might want to disable this. So if I'm wanting to create a table, and I'm going to call it and system user, let's call app user. So this is a great example. So I'm going to put app user ID. Let's just do user ID. User ID int primary key auto increment. Username bar chart 30 not null. Again, that's a constraint while we're on the topic. So it can't be null. I'm just going to put in a password. We want to be secure, so we're actually just going to store the hash. And then finally, I want some metadata about my user. So often in databases, we have what's called the who audit columns. And basically what it is it's who created it, when did they create it, who updated it, and when did they update it. So created at, is a date time, not null. We don't want it ever to be empty. Default is current timestamp. Created by is an int and not null. Because basically what we're going to do is we're going to say an app user is created by another app user, right? So like if I'm the first app user, if I'm the first user, I want to track, all the people I create. But then if I hire someone else, I want to know who they create, and so on and so forth. So let's just stick with that. We won't do the updates. But what we want to do is we want to have our constraint, and we're going to call it user fk app user fk1 foreign key, and it's on the created by, and that references itself, which is a little funny. App user ID. All right, so I'm going to create this table. It works. Basically, this column here, this created by, references its own table. And so now if I try to do an insert, so let me just refresh this. We'll just make this easy. If I go here to app user, and I'm going to copy to clipboard and insert statement. And let's just plug in some data here quickly. Oh, let's just make her admin here. No, since that's a default, we can just leave that off. And our created by is interesting because right now we don't have one. But let's just say we're going to put one in here or leave null or whatever. Now, if I do this, you'll notice that it says, I guess I need to delete that one. There we go. Oh, and maybe I have my checks turned off. See, that actually worked, which it shouldn't. So let's, who knows what I've done with this one. So let's truncate app user. And let's use that fun little bit of code here to make sure that we have this on. All right, so now my foreign key checks are on. I'm going to try to run this again and it works. So I'm not quite sure what's going on here. Constraint app user, maybe it does it by default. Let's try 2. Let's try 4. Okay, so that one works. So apparently MySQL circular imports work where it actually, I guess, insert before it checks. That just seems weird. Okay, apparently this one works to where you can actually get it inserted. Because if I try 4, which doesn't exist, it fails, which is what I was actually anticipating because I know in Oracle it does. So, with a circular import or a circular constraint, foreign key constraint, typically the foreign key has to exist before you can insert it. But where this one's a self one, MySQL must work, which is honestly quite convenient because that's always one of the biggest pains when you're developing something, trying to insert it. And it's like, wow, this isn't working. It becomes very problematic. So I'm actually glad we did that. But anyways, that's interesting. All right. Any other questions?
Do you have an anticipated date for feedback on final projects that have been submitted?
Well, have you submitted it?
Yeah.
Okay. Yep. I will check. I might just be past my thing because normally I get those done fast, but I just didn't know it. They'd been submitted. So I'll get to that today because I usually try to do those really fast.
Thank you.
Yep. All right. Well, if there's nothing else, I will let you guys get to your evening. Thank you for being here.
Brother Crook,
Yeah.
Thank you.
on the final exam,
Hmm.
I was reading the directions for it, and one of the lines says that there's only one attempt on it, and then further down it says there's 2 attempts on it. I'm just curious if it's 1 attempt or 2 on that test.
That is a good point. Let me take a look.